Hi, this is Gunasairan, Assistant Professor for Mechanical Engineering at SNS Institution. Now we are seeing about vapor compression refrigeration. Okay, vapor compression refrigeration is a widely used refrigeration and air conditioning method that operates on the principle of removing heat through phase change of a refrigerant. It involves four main components: compressor, condenser, expansion valve and the evaporator. The refrigerant absorbs heat in the evaporator is compressed to a high pressure gas, release heat into the condenser, and then expands it and cools before repeating the cycle. This efficient system is commonly found in refrigerant, air conditioner and industrial cooling applications. Okay. Here we are seeing about four important components: compression, condensation, expansion and absorption. First we are seeing compression is the first stage of the vapor compression cycles, where low pressure, low temperature refrigerant vapor into the compressor. The compressor increasing the pressure and temperature of the refrigerant, converting to the high pressure, high temperature gas. This process is essential because it raises the boiling point of the refrigerant, allowing it to release heat in the condenser. Various types of compressors such as a reciprocating, rotary or scroll can be depending on the applications. The work done by the compressor requires the external energy, electricity, and plays a crucial role maintaining the continuous refrigeration coolings. Second one, condensation is the second stage where high pressure, high temperature vapor refrigerant from the compressor enter the condensers. Okay. In the condenser, the refrigerant release its heat to the surrounding environment, usually air or water, causing it to the condense into the high pressure liquid. This heat exchange occurs without changing the pressure, and it transforms to the refrigerant from a gas to the liquid stage. See that here condenser is changing from gas to liquid state. Condenser can be air cooled, water cooled or evaporating depending on the system designs. The purpose of this stage is to be prepared the refrigerant for expansion and cooling by removing heat absorbed during the evaporation and compression. Okay. Third one, expansion is the stage of vapor compression cycles, occurring after the refrigerant has condensed into the high pressure liquid. The liquid refrigerant passes through an expansion valve or capillary tube where its pressure suddenly drops. This drops in the pressure causes a portions of the refrigerant to vaporize and cool rapidly, okay, resulting in a lower pressure, lower temperature of mixes liquid into the vapor. These cold mixes then enter to the evaporator. This expansion process is essential because it reduces the temperature of the refrigerant. Okay. Finally, we are seeing about vaporization. Vaporization or evaporation is the final stage of vapor compression cycle. Here, the lower pressure, lower temperature refrigerant enters the evaporator and absorbs heat from the surrounding, such as air inside as refrigerator or a room and air conditioner. As the refrigerant absorbs heat, it changes phases from liquid into the vapor. Okay, here mainly used for liquid into the vapor, completing the cycle. Okay, then see that vapor compression cycle. Compressor, the function of compressor to remove the vapor from the evaporator and rise to the temperature and pressure at a point. Okay, discharge line. A hot or discharge lines delivers to high pressure, high temperature vapor from the discharge of the compression air conditioner. Condenser, the function of already we are seeing that, but heat transfer through the heat passes from the refrigerant vapor conditioner mediums. Okay. Reservoir tank, a reservoir is used for provide storage for a condenser liquid so that a sorry constant supply of liquid is available to the evaporator as required. Okay, liquid line, a liquid carries the liquid refrigerant from the reservoir tank to the refrigerant flow control. Expansion valve, it is a function to the meter to proper amount refrigerant to the evaporator to reduce the pressure of liquid entering the evaporator that liquid will vaporizing. Okay, suction lines, the suction lines convey the lower pressure vapor from the evaporator to the suction inlet to the compressor. Here merits, the vapor compression system is highly efficient and widely used in refrigerant and air conditioning due to the performance. Okay, it provided effective cooling over a wide temperature ranges at high coefficient of performance, making it energy efficient. The system is compact, reliable and suitable for the both domestic and industrial applications. It allows precise temperature control and can use various types of refrigerant. Okay, then demerits of refrigerant is a high cost, and vapor compression systems several demerits. It relies on electrical energy, leading a high operating cost, especially in large scale applications. This use of sudden refrigerant can global warming, mechanical components like compressor require regular maintenance and can be noisy. Okay, thank you.